Welcome to MAGPIEHUB. In this comprehensive NEET physics lecture, we will cover vectors and motion in a plane. This is one of the most important topics for NEET examination. We will learn about scalars and vectors, vector addition and subtraction, dot and cross products, unit vectors, resolution of vectors, relative velocity, projectile motion, and uniform circular motion. Let's start with the fundamental difference between scalars and vectors. Scalar quantities have only magnitude, with no direction. Examples include mass, temperature, time, speed, and energy. Vector quantities have both magnitude and direction. Examples include displacement, velocity, acceleration, force, and momentum. Remember, velocity is a vector but speed is a scalar. Vectors are represented by arrows. The length of the arrow shows the magnitude, and the arrowhead shows the direction. Now let's learn how to add and subtract vectors. There are two important laws for vector addition. The triangle law states, place the tail of the second vector at the head of the first vector. The resultant vector goes from the tail of the first to the head of the second. In the parallelogram law, both vectors start from the same point. Complete the parallelogram, and the diagonal gives you the resultant vector. The magnitude of the resultant is given by this formula. R equals square root of a squared plus b squared plus 2ab cos theta. This formula is very important for NEET. For vector subtraction, a minus b equals a plus negative b. Negative b means we reverse the direction of vector b. Then we add them using the same addition rules. Now let's understand the two types of vector multiplication, dot product and cross product. The dot product or scalar product equals a times b times cos theta. The result is always a scalar, meaning just a number. Remember, I dot I, j dot j, and k dot k all equal 1. But I dot j, j dot k, and k dot I all equal 0. The cross product or vector product has magnitude a times b times sin theta. The result is a vector. Important, a cross b equals negative b cross a. The direction is found using the right-hand rule. In component form, the dot product equals axbx plus ayby plus azbz. This is very useful for solving NEET problems. A unit vector is a vector with magnitude equal to 1. It only shows direction. To find a unit vector, divide the vector by its magnitude. A hat equals vector a divided by magnitude of a. The standard unit vectors are I hat along x-axis, j hat along y-axis, and k hat along z-axis. Here's an example. For vector a equals 3I hat plus 4j hat. The magnitude is 5 using Pythagoras theorem. So the unit vector is 3I plus 4j divided by 5, which gives 0.6 I hat plus 0.8 j hat. Resolution of a vector means breaking it into perpendicular components, usually along x and y axes. The horizontal component ax equals a cos theta. The vertical component ay equals a sin theta. These formulas are extremely important for NEET. Here are all the important resolution formulas. The magnitude can be found using Pythagoras theorem, and the angle using inverse tan of ay over ax. Relative velocity is the velocity of one object as observed from another moving object. The formula is simple. Velocity of a with respect to b equals velocity of a minus velocity of b. Remember, it's always the velocity of the first object minus the velocity of the observer. For same direction, subtract the velocities. For opposite directions, add them. When at an angle, use the formula with cosine theta. This is similar to vector subtraction. A classic neat problem. When rain falls vertically and you run horizontally, the rain appears to fall at an angle. This is relative velocity in action. Projectile motion is the motion of an object under gravity in 2 dimensions. The path is always a parabola. A projectile is launched with initial velocity u at angle theta. It rises to maximum height h max and lands at horizontal distance r, called the range. Here are the key formulas. Maximum height h equals u squared sin squared theta over 2 grams. Range r equals u squared sin 2 theta over g. Time of flight t equals 2u sin theta over g. Memorize these for NEET. Important points. Maximum range occurs at 45 degrees. Complementary angles like 30 and 60 degrees give the same range. At maximum height, vertical velocity is 0. In uniform circular motion, an object moves in a circle with constant speed. But the velocity keeps changing because direction changes. The velocity is always tangent to the circle, shown in green. The centripetal acceleration, shown in red, always points towards the center. This acceleration is what keeps the object moving in a circle. Omega is angular velocity equal to 2 pi over time period. Linear velocity v equals r times omega. The centripetal acceleration AC equals v squared over r. Centripetal force equals m versus squared over r. These formulas are must-know for NEET. Remember, velocity is tangential. Acceleration is centripetal, meaning towards the center. Speed is constant but velocity changes because direction changes continuously. Now here are some important NEET exam tips. First, master component resolution as 80% of problems need this skill. For projectile motion, remember maximum range occurs at 45 degrees. And at this angle, maximum height equals 1/4 of the range. For relative velocity problems, always draw the vectors first. Then subtract. For cross product, use the right-hand rule to find direction. If dot product is 0, the vectors are perpendicular. For circular motion, centripetal acceleration always points towards the center. Practice unit conversions. To convert kilometers per hour to meters per second, divide by 3.6 and memorize common trigonometric values. Here's a quick formula recall for your exam. Range equals u squared sin 2 theta over g. Maximum height equals u squared sin squared theta over 2 grams. Centripetal acceleration equals v squared over r. Thank you for watching this complete lecture on vectors and motion in a plane. If you found this helpful, please like this video and subscribe to NEET Solution at MAGPIEHUB for more physics lectures. Share this video with your friends who are preparing for NEET. Good luck with your preparation. See you in the next video.